the presentation for whoever actually wants to work on the workshop, hence the work in the workshop. So if someone does plan on getting the source code and seeing the presentation while I also talk, you can just get it from here. Because my presentation also has solutions. So if you want this, okay, otherwise. Okay, I saw some people. Did you all got it? Okay. So we're going to talk today now about smart contract security and smart contract audit. This workshop is also a part of the same ETM for Everyone book that will be held at University in Cluj, if I'm not mistaken, or if I didn't make such a bad job and it will not be included. A little bit about myself. I'm a smart contract security researcher, over 10 years in security, both Web 2 and Web 3, a lot of million TVL, total value locked smart contracts that I've audited, over 40 private or collaborative audits. I did a lot of work over the years. This is just short, so you know who you're speaking. I'm Abba, the blue one. You can find me here. So they were going to talk about, okay, what is security as and why do we actually need it in blockchain? No one's actually had ever the need to secure a bear because there's no incentive to attack a bear. You only need security on something that actually has an incentive to be attacked. I'm going to explain why. Some common smart contract vulnerabilities, and here some hands-on exercises. Sorry. Hello. I can fail at using the mic. Hey. Hello. Sorry again. Okay, so we're going to talk about smart contract vulnerabilities, the common ones, some examples hands-on, risk assessment, where I'm going to try to give you a quiz. Best practices, what's auditing, blockchain security there isn't just a state of the art. Gonna go to it kind of quickly because I don't actually expect anyone to remember all the links or tools I'm gonna mention. The idea is to have a good overview. Okay, starting, the idea is what is security? Protecting, making something more resilient. Why do we need in blockchain security to make stuff more resilient? What's the harm? Well, we need to think about the blockchain in terms of what can you do with it? What's different about it than other technology? One, anyone can create anything. You can say that normal development has this. Yeah, anyone can create any software, but here anyone can attribute any financial value. This is different because in normal Web 2 development, not everyone can make a bank. Not everyone can make a payment processor. You need a lot of work, a lot of financial audits and security. Here, anyone can do anything. That's why you also need security on this part. So basically thinking about this, everything is a fintech, and everything being a fintech, it's about the money. Put it basically, because you can steal and anything can have a financial value, you need protection. You need to think about blockchain security as in the entire ecosystem is manufacturing cars as a service, brokerage as a service, banks as a service, casinos as a service, anything that you've ever had the financial value and incentive associated with it. It's how you need to think about blockchain technology, and that has the answer of why we actually need security. Now, people from Web 2, when they come to Web 3, they usually come with this in mind. Move fast, bake things, make a good, that's how you do it normally in development, but this doesn't work here because moving fast bakes things. This is a different thing from normal Web 2 development, because if you actually deploy something with a bug and fix it in production, you don't have one or two angry clients, you have theft. That's why you can't do this. That's the need for security. This is literally the general introduction of why we need security that I've talked about. Now, vulnerabilities. The entire ecosystem is somewhat new, and over time, vulnerabilities and hacks appeared in the ecosystem, so some categorization appeared on those vulnerabilities. I'll mention a few of the most common ones and their impact in the last 2 years. Access control. There was a failed attempt that Consensus had of making a standardized way of defining issues, severity, and vulnerabilities. They tried. It's not like normal Web 2 security when you have specific threats that I've identified and meet a standard, if I remember those correctly. So you kind of need to define it on your own. Look how general people define it for now. Classic ones like access control. Stuff that should not be allowed by anyone to do is allowed by anyone to do. This actually is this is something that people don't actually expect to still exist in the wild, but still exist. I mean, code that is accessible by anyone still deployed. Lack of input validation, as in smart contracts, like the previous presentation showed. You can think of a smart contract as the entire API itself, the endpoint itself. This is different from Web 2 programming because in Web 2 you need a server, you need API nodes. Someone makes a Swagger file, you have a lot of layers between a user input and the actual backend logic that executes it. Even then, hacks in Web 2 happen. Here, my function is actually going to be called from a random place on the earth. The function itself, not an endpoint. So you also need to validate the input of users, and not doing that is a vulnerability. There's a difference between a vulnerability and the cause root of a hack. For example, inadequate price dependency. You're not implementing on-chain a good mechanism for checking price. That's the vulnerability. The hack is a price worker manipulation. Sometimes you're using those intertwined. So access control is a type of vulnerability and a type of root cause. You do get the idea. Precision loss happens in smart contracts, mostly EVM. There are no floating points, as in you don't have 0.0074, no. We have only fixed arithmetic mathematics, which means that when you divide something, each and every division, you lose the remainder. That's a precision loss. And if you don't actually know or do that precision loss intentionally, you can have an issue. Those are actually really, really hard to figure out and still happen today in the wild. Reentrancy is one of the more interesting ones that happens that Web 2 developers don't really think about it when they come here. From within a function, you re-enter the state of the same function. It's a type of recursion up until one point because you can't go indefinitely because it will break the contract. And by doing that before modifying state, you have unintended side effects. These are all kind of generic because I would need examples for each and every one of them, and it's going to take a while. We're going to have some hands-on with one. Logical bugs are the ones where you can't really categorize them as business dependent and you just put it in this category. Someone made a game that you can arbitrarily steal from someone else, that's a logic bug, or you can DOS someone, still a logic bug. These are two graphs from Chainlight in 2023 and 2024. How much, for the one in 2023, we have how many D-hacks that happened, the distribution of errors, the vulnerabilities, which were the most as count. So basically, in 2023, almost 51% of all hacks were logical errors. We had still reentrancy at that point. Access control, there are errors. In 2024, I have numbers as in how many millions were lost per each vulnerability type. Logical errors will kind of always be, over time, only logical errors will probably remain because those are business dependent and the other ones, when you can categorize something, you usually can fix it at one point. You have standardized ways of dealing with it. When you can't categorize it because it actually depends on the business logic of the protocol, that's where ingenuity and human creation happens. Now the exercise. Whoever of you got the presentation and wants to do the exercise, there is, you will get, this is the repo. We get, and there you have an exercise which we can do. Okay, I'll kind of try to yell. Is someone here who's gonna try to do the exercise? If not, I can just present how it happens, but if not, I can let you to try a bit. There is no shame in saying that I don't actually want to do it. I know there's a workshop you have to work, but it's okay if you're not. I'm gonna presume no one actually doing it and gonna start explaining it, which is okay if someone actually does it. Okay, put this here. So, lol. So this is the exercise, and you would need to get the repo locally, and you'll have the entire description is, okay, we can move back to the description a bit for some. Far away land, governance wants to reward its users. Some users, it's you humans is citizens. Some citizens are happy, some citizens are not, they want to steal. And it's your job to try to realize how to do that. As an auditor and in security, you need to think as the bad guy to break it. So this is an example of let us try to actually break it. The code, if you download it, and what's a bit, wait. Sorry. I'm not seeing it this here. That's why I'm a bit whatever. Just a bit. Just a bit for the fuck. A bit of technical issues. The fuck? Just a second. In doing this time, you can try to do it on your own if you want. That's gonna happen. I have no idea how to do this. We're still failing at this, but we'll try. Can anyone from the staff come here a bit, please? Sorry, a bit. Vii puțin, te rog. Bun, boss.
Te-au hackuit băieții?
M-au hackuit băieții, am scos aia și nu mai vede acum. Am scos și am băgat aia că am avut o problemă și încă mai am. Și tot nu văd. Și acum mă văd. Am băgat bunul?
Ai și HDMI.
Da, păi ambele le-am băgat.
Păi da, pentru că ai băgat cablu care nu e băgat în...
Nu, dar ea mergea până acum, am scos de aici.
Jur că nu.
Nu, ăsta nu avea treabă, l-am băgat acum. Ăsta alt am băgat, uite, e băgat.
Deci asta n-avea cum. Hai să încercăm și ceva.
Bagă-l și, da, să vedem cu ăla de cum e. Scuze. Scuze.
Cred că poți să-i dau restart la ecran.
Nu știu. E și problema la căcatul ăsta. Da, te rog.
Nu are să
Da, e băgat, mai înainte a fost și l-am scos.
Have you tried turning it off and on again?
Only the laptop I need to turn off and on. I'll try with the laptop, okay, but this... Bun. Nu știu.
Asta l-ai folosit înainte. Celălalt HDMI?
Da, ce mai aș de mii, numai nu am putut să-l fac să... Cred că e problemă de Linux, să-l fac să display-ul să duplichezi și am vrut să încerc. Și
Da, eu folosesc tot timpul duplicarea Linux, că și am prezentat aici
Bun.
cu Linux.
Da, e aici
Și
atunci.
Go.
Că eu nu folosesc pe ăsta niciodată. Și nu știu de ce nu merge.
You want to try using my laptop?
Give me a few more minutes, and if not, I'll probably need to. I was actually looking at that one. Cu timpul. Mai avem timp. Tot aici, cam o dilemă. Bun. Stai, nu. Uite, boss, cum fac căcatul ăsta să fie numai un screen?
Settings,
Nu mers la mod.
display.
Păi să mă uit tu că acum le vezi.
Nu înțeleg cum știu.
Nu joc.
Mirror.
Mie. Aia, pula mea.
Și te rogi. Nu funcționează nimic.
Ba, nu știu.
Ok.
Okay. Thank you for your patience. I hope you made the exercise during that time.
Is the goal to get the attacker 56 points instead of the
What?
task was to have the attacker acquire?
Yes, the task was to have the attacker acquire 56 points. Okay. In case no one knows what this beauty is, it's File Archive Manager. I recommend you use it. I don't use the terminal within Visual Studio Code. I know people use it, but no, I'm using separate CLI tools. Okay, so this is the first task about how to make how to have 56 coins. Basically, there is a treasury, and someone sets the winner of it. The owner, the treasury deploys its own golden tokens. The owner, only the owner can set the winner, and then at one point, any set winner can call, and he will get the coins minted to himself. The gold coins. The gold token is gold token, which has a mint, only the owner of it. When the gold token is deployed, the owner is set as the deployer. Remember, the deployer itself, the treasury is the deployer itself, so the treasury can call this mint, which will get this mint, which will call this mint. And the gold token itself is an optimized ERC, where you have to believe me that I optimized by removing the context. The context is a part of OpenZeppelin's context that works for meta transactions of message sender and message data. Wonder, I removed it. Okay. Now, you as whoever failed or tries to attempt this, start at this test. Better? Okay. Basically, the winners are the hero of Nightingale, a slayer of words, random peasants, city guard, and you have yourself the attacker. I saw the other presentation that he had raw addresses. You can also use make address. It's funnier like this. So basically, the setup is called. Each user has is set by the governance a set amount. Then this test actually shows that they can claim the rewards, and then the attacker starts its bank. The start bank is the equivalent to use bank from the other presentation, only works on more operations, not just the first one. So, and this here you should add the code. Now, since the idea here would be, since I told you steal coins, you will need to look as an attacker on the treasury itself. You can see here, okay, how can we have code here that does, someone needs to call this. This has a only owner. So as an external attacker, I cannot influence this. Claim only if I was set. If nothing was set, this defaults to 0. User has no winnings. Okay, how then can I do it? Okay, when you attack, you need to check every single thing that's on chain. In this case, let's look at the gold token itself. The gold token itself, let's see, okay, it's another owner, the mint. Okay, you have only the owner, which was the deployer. Oh, fine. Whenever you see an optimized something, look for errors, because optimization breeds errors. In this example, which if someone would have tried to look at it, I'm being passive-aggressive without any reason, you will see that, yes, I did remove the context from here, but there's another thing. I copied this from OpenZeppelin, but between the entire dependencies, there can be issues that you don't realize. For example, while I was optimizing, I mistakenly put the underlying mint to public. Now, this is easy if I'm showing you this, but this is not easy. Imagine someone's looking at the contact on chain. Oh, good. Oh, good. Oh, good. But this, wait, this is a lot of code. OpenZeppelin copied. It's a single small change somewhere, which you didn't realize, which is enough. Now, to actually make it, to make this attack, you need the treasury, gold coins, because it's in the public variable, the compiler creates by default a getter. That's why it's a callable function, the gold coins here. And while this sees only the mint, we know that actually there is an underlying mint there. I don't know why it moved here. And the underlying mint had who to get transferred the attacker, let's say who to transfer the tokens to, attacker. It still should work. It's not, but it still should work, because the interface is just a way of telling it locally what you have. Nothing stops me on chain to call it. But if you're right, I'll see. The keyword ether means actually 1 to the power of 18. It's not actually 1 ether. It's just a way of, instead of saying multiplied by 10 to the power of 18, I just say 60 cipher ether. And let's see, and this should probably, no, yes, not the sure. This should probably work. Of course, I double checked it, and at one point, it worked. Hacker gonna hack. It passed. If we look about what, sorry.
Shouldn't you use the mic?
I cannot have the mic and write, so sorry about that. Look here. the idea is after the prank, let's say if we commented out, you see then the message would have been attacker must have what I wrote here. Asserts can also have a message. You can write a descriptive message what said happened. So
If you call mint without the underscore,
if
it should do fall.
it should fail because mint without the underscore, which Visual Studio did see, he did not see in the inheritance that there is an underline one that is also public. Also, there is the false concept that underline means private. It's just a naming convention. Nothing actually stops you from making it public or external. I could not put it because it can be inherited. If just the mint, like this. Now, I know that this seems simple, but the idea is these happen. Like, this would be the solution. Just a mint goes to here, goes to the optimize where we have it, and it's public. This was a hack that happened last week when someone literally forgot to have a gated mint and they lost only $140,000 because they minted like 20-something million. Well, no. I think there was 27 million equivalent in value, but there wasn't underlying liquidity for it. The idea is people actually just forget to put a, and it was again a mint in the dependency because the dependency by default didn't have one and they forgot to implement. Next one, this is gonna be the too easy box because it's too easy. But let's see how we have the time. Oh, we have time. So this task would be a bit more complicated. You have a contact, like the name suggests, is a place where people deposit stuff and other people get the stuff. A courier puts ether in it, and a hacker gonna hack dudes wants to get, you know, there's always someone near the boxes, the real life easy boxes, who looks at them. That dude wants to take stuff. And in this case, you will also need to to see how we can exploit this. This is a bit more complicated. If you can see there, the too easy box. Now. This is the too easy box. Oh, sorry. This is spam. Very simple contact. Someone deposits, anyone can deposit, and then you withdraw. You make sure that you actually have something to withdraw, and only the contacts that have been deposited to can deposit. This function sends you back your ETH, sets it to 0, we're done. And you can just get the contact to see how much. This is the too easy box. Yes. This is the classical case of reentrancy. You have a gazillion dollars, you have the courier puts to random Joes, dudettes, Marcy, attacker, and we have the attacker. In this example, you only get one ETH. And with that one ETH, you need to get the entire balance of the too easy box. This has an irrelevance at one point, but for now, I'll leave it like this. Hacker's gonna hack. How are we going to do this? Now, because I don't really want to code in public, I'll just copy the solution. Yes, of course I have it locally. Someone said how of course I have it here. Yes, you're going to see exactly how I've taught it because it's easier this way. And I'm no shame. Okay. Someone said reentrancy. If you remember, reentrancy is coming back within the same function. How do you spot these types of issues with a reentrancy? Okay, anyone can call it. This helps because you have a controllable attacker-initiated entry point. You have the side effect. In security on blockchain, there is the cause-effect interaction pattern which says, first you must, cause check interaction. Checks interactions. And first of all, you need to always do the updates of the balance before doing the interactions. In this case, the interaction is when you're calling this function. What does that matter? This function of calling another address can trigger a hook, a callback. This can only happen if you have a smart contact that calls this function. So let me give you an example of an attacker. This is the one that magically appeared. So this function, receive external, is a classical function defined by Solidity and the compiler and logic itself. If a contact is intended to receive native EAT, it must have this one or a payable fallback. What does this happen? That means when anyone sends EAT to this one, this contact will check if the too easy box, it could have checked if the caller itself had this balance, and it will call withdraw again. You see the idea? Nothing stops me from doing this in a loop. Think about it from how would you actually implement this if you had the time. Import. Okay, we create the contact. Remember, the attacker has only one EAT. This was somewhat relevant because in a homework manner, I would give you a harder version. We start the attack. By starting the attack itself, so first of all, deposit in the contact. By depositing one EAT, we have the first requirements that we need to have an initial balance. Now, starting the attacker attack, come here, attack initiates withdraw. We go to the withdraw. Do we have a balance? Yes. Cool, calling it. This call means transfer EAT to the caller. Then the attacker will get his EAT. Now, if the box still has still has EAT, we call it again. See the logic? We come here again. Now, the update, the effect, has not been applied because we are still here in the first re-entrance. This is the second re-entrance. We're going to reach this call and enter it again. And come here and enter it again. And come here and enter it again. At the end, in each of those calls, you'll just reach this one, which sets it to 0. The first one will set it to 0. The other 10,000 will also set it to 0. And it will not revert. For example, if I would have done here, if I would have put an amount, and you would have done an amount, and I would have deducted the amount, then you couldn't have done this re-entrancy because it would be an underflow at one point. Here, just by setting it to 0, I allow this case. I'll show you again in... OK, this is just to show that the hackers and the hack works. I'm going to put a few more V's. V's is for verbose in Foundry. And you can see that you cannot actually see. This shows how many execution, and there are a lot. And if we go in this example, this is a view. Attack. You initiate the attack, which initiates a withdraw. The withdraw calls it, and it calls again, and again, and again, and again. These are classical re-entrancy issues. This is the classicalist example and simplest possible, and it had a hack. I mean, in 2016, there was a large hack about this, because at that point, no one knew about these issues.
How long does the call keep happening?
Exactly, a good point. The call keeps happening like the way I made the code, depending on how many times I need to call it to block to stop it. So if there is a balance in the too easy box, the malicious code calls it again. And it only steals one EAT on each call. So to answer your question, it needs to find out how many EATs already there. So like 10, 20, 30, 41 times.
Assuming
Actually,
the max gets.
What?
Assuming you have enough gets.
For 20, whatever, for 42 actually with your own, is you have enough gas. Now, if you want to complicate your life, let's say there will be 100,000 ETH in this one. I'll just show you that this naive approach doesn't actually work if you have, I should have that amount. It shouldn't actually work because, maybe there's not. But this one would be too complicated to implement. Wait. Hey, there's $1 gazillion for the courier. Whatever, put more. At one point, there's too much recursiveness. Probably this failed because of this. Okay, too much can fail to send not enough gas because there is a limit to how much gas you can actually put in the transaction. Therefore, you cannot have at many points. Homework, if you ever want to do this, how would you modify the code to do it like so? I can give you a hint now because probably no one's going to actually do this. You need to think about this one in a duplication manner. Let's say there is balance. First, deposit. Then call withdraw again. Then my ETH becomes 2 ETH because I'm again depositing the one that I already deposited becomes 2. Then again becomes 4. 2 to the power of. And then you stop and have another logic if you do need to increment again. That point, this simple single function cross reentrancy becomes a more cross-contact reentrancy. There are several types of reentrancy. You have the classical in the same function. You have the cross-function reentrancies where you go to multiple functions within the same contact. You have cross-contact reentrancy where one contact depends on the other and the logic you go reenter in different contacts. You have cross-chain reentrancy, and there is even an other variation of read-only view reentrancy where you modify the state which is used by a view function from a different protocol, which basically is used for Oracle manipulation. That's the most common case, sometimes modifying the underlying amounts while a different protocol still use the view with the older one and you have a hack. You can complicate the hell out of it. That's why they still exist. There's still issues with the reentrancy. No one's claiming to fix it. Basically, you can bash away with putting a modifier, but you can't really block all of them without knowing. This is a very classical and good case. You'll see it reentrancy as like the best known case of issues in the ETH. Okay, now risk assessment. I'm telling you now, the ecosystem is still young. There isn't a standardized way of defining issues. So we have like the risk is associated with an issue. And we associate by severity. If an issue is highly severe, then it's high risk of happening something bad. This is a general way of, enough people are using this one, so I can present it here. Severity and risk assessment is how likely for something to happen versus the impact it has. And define it by low, medium, high. Now, so give you some examples. The damage. These are an example. Does the issue itself has a high impact, as in loss of a lot of funds, like millions? Yes, this is a high impact. But if the likelihood of happening is very low, like 1 in 10 years, it's not that risky. It's still an issue, but then you would make itself as a high impact, low likelihood, medium. It depends. It depends. It kind of depends. Now, people are not actually in agreement with what is likelihood, what is impact, because likelihood means how often do you need to call it to happen, or if you actually need to call it to happen, do you need to call it once? Is it if I call it once per year, and it has a 100% rate of reproducing the same as me calling it 100 times a year, but 1 in 100 actually reproduces. There's a nuance there, and it's not that standardized. Now, what is standardized is what you need to do about them. Critical highs must fix them. Medians should fix them. Lows can. This is actually good wording, can fix them. And the other ones, informational, like my favorite ones, I just put them there and typos and stuff people ignore. Now, quiz. for you. Do it. This is actually a quiz. I'm going to have questions. How would you rate severity on some stuff? When you all have it, I'll need to actually start the quiz. Do you have it? Okay. I see 3 participants. This is the first time I'm using this, so I probably have issues. Oh, 6 participants. 7. You are all in? Okay. Lol. You have 45 seconds per question. Go. Lol. Do you want the music? Oh, I can actually see the... I'm leaving the elevator music. Damn, someone said 0.0. Nice. Continue, dude. You finished? Nice. Ah, you're the one who just pressed OK on everyone to fail intentionally? Oh, okay, you actually thought about it. Okay.
I assessed differently.
I agree. That's the idea. Everyone assesses differently. I'm just giving you one subjective way of interpreting it.
Okay.
There are 15 questions. 15 questions. So we're then going to discuss them in the presentation, but I wanted to give you an idea of what we'll discuss. Zugi. So 2 people finished all of them, I guess. Bobby, you can overtake Alex, wherever Alex is. The VC, hope you have enough funding. It's cute. Okay, 2 more people. Bastios. And VC. Come on, VC. You're getting close. Okay. Just 1 VC. Okay, let me see if I can eliminate the test, dude. I sure want to remove yes because he didn't say anything. I'm sorry, tests are not allowed. Bobby, Alex. Who's Alex? Bobby and Alex. Who's Bobby? Yeah, you're Bobby boy. And VC?
I think this is my technical.
Okay. Now, I'm going to give you an explanation subjectively what are the actual answers according to what methodology I chose, because again, it sort of depends. First of all, I wanted to have the questions one by one to not give hints about the other questions, so you need to decide. A user loses $50. there isn't actually enough information about that one. Or what does $50 means for us, for an individual? So you can't really tell on that one. Now, a user uses $50 out of, the word uses, out of a $500. Well, that's like 10%, that's kind of a lot. There isn't, someone may not agree, there isn't a justifiable way of losing that much amount on an input of a smart contract. It's too much. You cannot say it's a rounding error at 10%. Now, 50% out of $50 out of 5 million. I put it as depends. Why? Because there is a case which, regardless of amounts, you will lose it all. The other ones per year, per day, will just follow this because I asked impact, not severity. The per year, per day depends when you want to say the severity of an issue. I just wanted the impact. But you would probably thought, that's the idea. When we, as an auditor, I need to separate the likelihood of it happening with its impact and then choose the severity. But it's a bias, human bias, to actually think in both likelihood and impact and say that the impact is actually a severity. It's a bit tricky. So basically you ignore those with time. They're the same. Like user loses 50 per year, it's still the same in my idea as not enough information. Again, this is not exactly a standardization, but we need to choose one at one point. Now, we have these. Here I changed the question. Suffers a theft and suffers a rounding error of the same cases. Now, either way, when someone steals from you, that's a high severity. There's some protocols or some platforms do have like some cases, but theft usually is high severity, high impact.
That could be critical.
That's the severity if the likelihood is mine. I'm talking strictly about impact. Impact, not severity, is critical if likelihood is also high.
No, could be critical with low likelihood.
Depends on, I know, I have you an example as the off one at Immunify who has that one, but generally no. General auditors have separated this. I'll give you as an, I've had an example. So all theft is at least high. Okay, someone used a critical. Now, rounding error of 50%, of $50, depends on the amount. A rounding error of 50 from the 500 ones, you have a 10% rounding error, that's a lot. That's too much, high. A rounding error of 50 after 5 million, it's like 0.001%. That's a low because it's expected. It's actually very good if you have only $50 rounding error on this one. That's why impact depends, at least it depends on the amount relative to the input amount and how the amount is lost. That's two fundamental ways that it does impact, generally speaking. Now, there are some examples, like a contest platform, Sherlock, defines significant loss if you have 1% of amount or more than $10. There's an absolute one. Fair. There are like Immunify, who says that if any amount is lost, that's a critical. They bypass likelihood and they bypass impact and just say it as severity.
Amount of user funds.
Of user funds, fair, not of protocol funds. There's a difference here. The idea is some use have their own way of determining severities, others have a more standardized. In between private audits, usually that table. It's the best we get so far. Okay, I'm going to speed run the next ones because the idea is just to present here. This was the only part of actually interactive. The security ones. Limit user interactions. If a user is not intended to call the functions, don't let him call that functions, never. If there is no incentive for him to call them, it means that you have not made the function for him. Limit as maximum. As much logic off-chain. You have a lot on the contract requires a sorted list, don't sort it on-chain. Sort it off-chain, send it on-chain, verify it's sorted, easy to do. Always validate user input. Even if you allow user, verify. Every single thing he puts there must be verified. Each and every rounding error, each and every division, you need to define if it's against or the user or the protocol. It must be against someone, you need to define it. This is tedious. This is very tedious. Devs don't do that. Multiple decimal tokens, you need to define each decimal. Look at each variable, what each decimal is. I'm giving just in the presentation and the book, you can read all about them. These are a lot. I mean, if I would go on all checklists, would be hundreds and tens of different things you need to check out. Basically, even subtractions. You have a subtraction, check because they can underflow. Try to do subtractions and additions. This is an example. If you're comparing a duration with a start, just move it around so you don't do a subtraction because it may underflow. Actually had cases, issues like this. Always reuse library code, the save versions. If you have a dependency, you must know it like you must know your lover. Everything it does, because it's a difference between library code integration and a dependency. Uniswap is a dependency. You have a dependency, you call a different contact. OpenZeppelin is a library, you get it locally, it's audited, it's okay for now. Format your code. Formatted code is always okay, as simple as possible, low-level code size, simple. Think as an attacker, find what's relevant, break it. Testing should be 100% coverage, should have fuzz testing, should have formal verification. These are fancy words 99% of protocols don't use. But I'm telling you, should. Obscurity, security by obscurity, meaning not validating the contact, or like Solana ones, I'm happy because no one sees my open source code. It's not, no, okay, maybe it delays by a day. Boo-hoo-hoo. Check all your sanity. If you truly are interested, get all the checklists in existence and check them yourself. Audit on-chain and off-chain. Smart contract auditing, finding bugs. You can only show that bugs exist. You cannot show that there aren't any more bugs mathematically. Formal verification can. What does an auditor do? Finds issues, makes POCs, suggests fixes. We also suggest fixes. Ensure everything is implemented correctly, compiles all the issues, given the report to the client. This is the job of a security researcher, basically a glorified tester, designer, system architect, and dev at points. The ideal smart contract loop for a protocol is they develop, go to a solo auditor, one individual, go to a company, more individuals, go to a crowdsourced security contest where people freely participate, then a bug bounty, and if at any point issues are found, they go again. No one actually does this, but this would be ideal. Generally, auditing is looking at code and understanding it. This kind of still applies, but it's kind of dying. The best auditors still look manually, the worst still use manually. They are in between that has like every single tool you can imagine and versions and whatever. Whatever helps you. Security today. What's really relevant today about security? Educational content, like Siphon Up That, Rare Skills, and Decent. There's people relevant in the ecosystem because there isn't enough information within the ecosystem for it. Crowdsourced security, I used the word a few sentences ago. People from around the world can randomly participate in a contest to secure your code for a chance of winning money. A form of decentralized security, crowdsourced security. We have contests, we have bug bounties. These are a few of the most famous ones. Security automation, this is where a lot of money also goes. Like how you have static analyzers, you have Slither, the best one, Magnus from Immunify, an orchestration of several other tools. You have audit agents. Everyone's trying to automate and eliminate us auditors because we're expensive. Normal. This is life, economy. Enhanced verification and tested, Certora Prover, which has formal verification. Open sourced, you have the Recon, which is a combination of fuzz testing, it has Medusa, Halmos symbolic testing, a lot, runtime verification from Raul, a lot of another form of verification. There's a lot of things going on, trying to make the need for creativity as slow as possible, as least as possible. Again, we want to eliminate humans. Normal. Conclusion, security is essential because it's money. Security exists as long as blockchain exists. If blockchain dies, security will die. Fair. $1 million worth stolen each year will always be $1 million worth each year. Best practices will reduce chance, even if you don't actually know what you're guarding against. You've just made best practices and you saved yourself. I think I put 2 times that day. Okay. Basically, that's it. one question. I need to go at the panel, and I suggest you also come with me at the next one.
So you said something for better security to use off-chain computations, right?
Move as much logic off-chain as possible.
Because, I mean, from my experience, it's quite easy to hack if it's off-chain, if it's on a centralized server, right? I'm not sure.
Statistically, I disagree with you.
Can you share the news, like even Microsoft servers, AWS servers?
I know, they happen. Must think about it in percentage. How much percentage of the entire global Web 2 infrastructure is hacked, and what's the percentage of smart contracts that are hacked and the targeted and the attack area? The more code you have on chain, the higher chances of bugs introducing. Off chain, like AWS, Microsoft, okay, you have 0 days, you have large entities that will target. There will always be 0 days, there will all be exploits in Web 2. But I'm talking about logic that it's not that critical. Like I gave you the example of sorting a list and putting a chain. State should be on chain, state that's relevant and used off chain. If you're off chain using just the logic to calculate and the state, which is money defining, is on chain, you're okay.
But what if you use encryption in smart contracts? So
There are forms of encryptions, but not relevant. Why? There isn't any good use case of using encryption on chain because you want to read the information, you want to have it. You can't. You're like, it's not. I cannot hash a password and save it on chain because anyone can read it. I need to define stuff on chain for which I use the blockchain as immutable, free for all to see, uncontested. I have a on-chain game. The scoring point is on-chain. The logic in which you calculate it may be on-chain, but you can put off-chain something like the list must be sorted.
Basically, the heavy computation.
As much heavy computation as possible, put it off-chain. But core logic, the one that can be hacked in Web 2 and in Web 3, should be, just the core one should be on-chain, minimal as possible.
Like for verification.
Yeah, for being verified that nothing actually bad happened. Okay.
Thank you.
Okay, thank you.